Good afternoon, everyone. Thank you for joining us for the first event of our Navigating Academia series. And as the title suggests, we will be hearing about the personal journeys of early career researchers, postdocs, and young faculties associated with geophysics. And we'd like to know their personal stories and how it shaped their academic path. And with that, it's my absolute pleasure to introduce Dr. Aklant Bhowmick here. Uh, Dr. Bhowmick completed his undergraduate and postgraduate degree at the Center for Excellence in Basic Sciences at the University of Mumbai, but he was awarded a full scholarship for his entire duration of study. This is the prestigious Inspire Scholarship from the Indian government, granted to only a select few every year. Dr. Bhowmick then went on to earn his PhD at the Carnegie Mellon University, working on quasars and high redshift galaxies with Dr. Tiziana Di Matteo. And immediately after finishing his PhD, he moved here to Florida and has been a postdoc and an assistant scientist working with Professor Laura Blecha. And as the next step to his academic career, he's going to be a postdoctoral fellow at the University of Virginia starting this September. So many of you have already heard Aklant talking about supermassive black holes and his work with illustrious TNG. And now his very recent set of own simulations that he put it up. And apart from his stellar academic profile, I'm sure everyone who has ever interacted with Aklant knows that he's a very positive guy. He always has a smile on his face and is one of the most approachable and uplifting people you would meet. And today we are basically excited to hear from him. So with that, without any further ado, I'd like to please welcome in joining Dr. Aklant.
Thank you very much, Abhishek, for too kind introduction. Now I'll tell you about how terrible academia is. So thank you again for everybody for being here and giving me the opportunity to speak about my academic trajectory. It's been a while since I've been here, and it was a great opportunity for me to also introspect about how far I've come and all the lessons I've learned and how I will take it over during the next course of my career. So here's my academic journey in a very small nutshell, chronological order from top to bottom. And as Abhishek mentioned, I started my pursuit of physics at the time, very little known institute called the Center for Excellence in Basic Sciences. It was an institute that was basically started in the mid-2000s as a consequence of a joint initiative between different pre-existing institutions in India, University of Mumbai, Department of Atomic Energy within the government of India, and several other premier institutions that already existed. And the goal was to basically come up with this new set of institutions to promote research and education in science, which at the time, a lot of people felt in India it could have used a huge boost. And it was a bit of a gamble for me to join this institute because I was literally the third batch. I was one of the first guinea pigs, so to speak. And there was no graduating class, so there was no way for me to compare the alumni to and their trajectories to compare as to how my trajectory would look after I graduated. And as a consequence, there was a bit of apprehension, especially from my parents, but at the end, they supported me a lot. Because it was really going against the cultural tide, so to speak, at the time, and I guess it even exists now, where the so-called Indian dream was to basically, right out of high school, go to a four-year degree college for engineering, get a job right away, or do an MBA and get an even better job, and then get married, have kids, and just live happily ever after life. So obviously, I did not want to live a happily ever after life, so I decided to pursue my passion for physics and discarded engineering option at one of the top institutions back in the day, Jadavpur University, by the way, where Abhishek is from Kolkata. And I joined Center for Excellence in Basic Sciences. It's a mouthful. So over there during my 5-year time, I got really interested in theoretical physics. I kind of liked experimental physics as well, but I figured for myself that my hands are a bit too clumsy to be good at experimental physics. That was always a bit of a bottleneck. And I also did not particularly enjoy the idea of like spending hours and hours inside a lab. So I decided theoretical physics was the perfect fit for me. And in my master's thesis, I worked on theoretical high energy physics, working on Higgs boson in the context of Large Hadron Collider. It was a really exciting field at the time because the Higgs boson was very recently discovered. So I played a lot with Feynman diagrams, quantum field theory, gauge theory, linear algebra, and I really loved doing that. And I did well enough in my master's research that despite having a rather mixed set of grades throughout my curriculum, comprising of A's, A pluses, all the way till B's and even some D's here and there, I was able to actually get into a decent school, Carnegie Mellon, which was pretty surprising because out of the 12 universities that I applied to, I got rejected by all 11, including my most obvious backup options. And at the end, after getting rejected, I got a call from Carnegie Mellon, one of the happiest days of my life. And after coming to Carnegie Mellon, I realized that high energy physics theory is not a very extensive field within that department. So I decided to pursue my other interest, which was basically this unsolved classical problem of turbulence. Luckily, I was fortunate enough to encounter a group over there, which was basically an applied mathematics group that sought to apply group theoretic techniques to solve hydrodynamic instabilities. And the entire idea of that was very fascinating to me. I've never heard of something like group theory being applied to hydrodynamics. It's a linear theory being applied to completely in highly nonlinear system of equations and Navier stuff. So it was very fascinating. So right away I joined that group, and the first couple of years were fantastic. I went to gave numerous talks, far more than many of my peers at that stage of graduate school. Got a first author paper and several second author papers, and I was en route to actually publishing multiple other first author papers. And unfortunately, tides turned a little bit for me at the time. Unfortunately, my advisor at the time had to leave the university. And there was a lot of political reasons for why that happened, and I didn't have the place to dig much into it. So I don't know why she left. And she didn't have any place else to go at the time, so I could not follow her to pursue the research I really wanted. So it was a pretty difficult predicament for me. I was close to entering my third year, and I had to switch research groups. I was still interested in theory, so I was looking for theoretical condensed matter, theoretical biophysics, but I was too old, so nobody wanted me. It was a bit of a liability. So in the midst of that predicament is when I finally chose the field that I'm at right now, which is astrophysics. And I surprised myself by choosing that because at the time I did not particularly like astrophysics. The one experience I had with astrophysics prior to that was basically this elective course during my undergraduate days, and it just left a bad taste in my mouth because I just felt like the course was not mathematically rigorous enough. I was used to doing group theory and second quantization and all that, and here they were just applying scaling arguments to everything. So I just did not like the idea of that. But nevertheless, I decided to give it a shot because what options did I have? And I told myself that if I continue to not like astrophysics, even after a couple of years at the time when I graduate, then at least I have developed a nice set of computational skills that I can switch to industry and just translate those skills. So with that in mind, I went into computational astrophysics for the next 3 years. And it was a bit of a mixed time. There was a lot of pressure to publish because people were already telling me that I was rather late in joining this field, which is extremely competitive. So I worked really hard, a little too hard for my own mental health. But at the end, things turned out well. I published a decent number of papers. I graduated on time, so to speak, with the wishes of my advisor. And then, so basically, I entered this field in the process. I didn't even mention the field, but cosmological simulations of galaxy formation. So one great thing that happened during that time was basically that I really developed a passion for astrophysics, something I absolutely disdained at the time. I really started loving this field. And that basically brings the first lesson that I learned in this entire process is that I stopped taking seriously my own likes and dislikes, because I realized that the reason why I like or dislike something is just a consequence of some limited biased data that I gathered from my limited experience of life. So why should I make a judgment based on that? So I decided to, from this point onwards, always be open to every field. And it would still might have turned out that I still dislike astrophysics, but it didn't turn out that way. But the ultimate point is basically to be open to anything, and this is the mindset that I keep moving forward. For some reason, if academia doesn't work out, I could join industry, but I think it would be very important for me to have that mindset if that needs to happen. Okay. So after developing this passion for astrophysics, I decided not to join industry and instead continue my academic journey. So I did a postdoc at the University of Florida, where I'm at for the last 4 to 5 years. And I had a fantastic time over here, great group of people, great group of friends, fantastic supervisor who supported me throughout the entire time. And that all manifested in the form of very high level of productivity. I was perfectly satisfied with the work that I've done during my entire time, and I got an opportunity to work in a really exciting field of modeling black holes in the cosmological simulation context, and also supermassive black holes in general, because this is a very interesting time for this field. JWST is detecting black holes at earliest parts of the universe. LISA is going to come in the next decade or so, hopefully, well, past the next decade, but close to that, and detecting black holes throughout the entire universe and the mergers. So I was very fortunate, and I'm really looking forward to this opportunity and continuing my research in my next stage of my career, where I will move to University of Virginia in the month of September. I'm actually moving out of Gates within 10 days. I'm spending some time at the University of California. So it's kind of bittersweet, but it will still be exciting times ahead of me, hopefully. And this will hopefully also be a stepping stone for my ultimate goal at the moment, which is to join a permanent academic position to make sure that I'm pursuing my new passion of astrophysics for life. All right, so this was basically the chronological summary of my academic trajectory. For the rest of the talk, I will tell you a little bit about, I'll basically scoop out parts of my academic trajectory and tell you a little bit about all the things that I've learned during this entire process, which have been valuable for me, and some of them might be very obvious to you guys. Maybe you guys have already learned it, but it's still nice to hear it from someone who's a little bit more experienced than you and be able to reinforce those practices. So bottom line is this. During my academic trajectory, I basically, in my mind, constructed these 4 pillars of professional development, which I realized that I have to really simultaneously work on all of these 4 pillars. And I'll reveal these pillars during the course of this talk first. So the first pillar is probably the most obvious one, the pillar of building the scientific knowledge base. And I'm sure most of you realize the importance of this pillar pretty early on. So I started, building this pillar at the very start of my undergraduate days, and it continued to build up just as a natural consequence of coursework. And this is really what you need to make that transition from undergraduate to graduate program, because you need good grades, you need to do well in the GRE, at least at the time, my time. So, but it turns out that once I got into really the meat of my graduate school days, I did not really invest too much in building this scientific knowledge base, because then once you get into like hardcore research, you just focus on this building deeper expertise on this very focused field. So that pillar basically fell by the wayside for the definitely for the last 4 years of my graduate school. And I also did not need it much, so that's just how it turned out. But in my experience, once I became a postdoc, I realized the need for resurgence of investment into this particular pillar for a couple of reasons. First, I started teaching, so I took some guest lectures for Laura as she was traveling in conferences. And in the process, I realized that if I really want to be a good, want to work in academia or one university or teaching university, I have to brush up on my fundamental concepts. And also, it really helped me put my research in a broader context, which helped me motivate myself further to do the same research. So what I was doing as a graduate student, I'm much more motivated to do it now, because now I'm more actively investing time in continuing to build that larger scientific base, of which my research is only an extremely small part, but it still fits really well into it. And also the third reason is that as you transition from postdoc to faculty, you have to go through interviews. And during interviews, you're basically meeting people who are working from a wide range of backgrounds. And if you want to hold yourself in a scientific discussion, then you have to understand their research in a very proper sense, but still be able to ask intelligent questions. So I found, especially during the peak of my job season, an increasing need to be able to brush up on my base scientific knowledge. All right, so with that, I come to the second pillar. The second pillar is basically this research-specific technical skills, and I'm sure you all have also experienced this. And I put that in a separate pillar compared to the first one, because obviously there's technical skills associated with building the scientific knowledge. But here I'm talking about those sets of technical skills which are basically kind of weakly correlated, if at all, to the ability to build conceptual knowledge in science. And this is very specific to different fields. For example, in my field of computational astrophysics, some of the research-specific technical expertise would include just learning how to use Linux, or learning how to navigate myself through a high-performance computing cluster, learning how to use AI and machine learning tools, and all of that, which may not necessarily correlate with my ability to understand fundamental physics concepts. And in my experience, during my time as a graduate in graduate school, it was really the expertise that I developed, this research-specific, purely technical expertise that I developed, which drove my productivity and drove my ability to publish papers instead of the first pillar, scientific knowledge base. Something that they never really tell you in undergraduate school. So I feel like the preparation for graduate school in that undergraduate stage is kind of lacking in that respect. And then the reason why it's even more important as you transition from graduate school to postdoc is because there's a natural expectation for a continued increase in productivity. And that might feel a little bit intimidating as a graduate student because you probably already feel like you're maxed out your working hours. So in some sense, maxing out your productivity. So how do you expect me as a graduate student to come up with more productive research when I'm already working at my absolute best of my capability? So fortunately, what I found in my experience is that this increase in productivity is not necessarily driven by suddenly you becoming more intelligent as you transition from, as you defend your thesis, you're a postdoc now, and there's a leap in your intelligence. That's not necessarily what drives it. Nor is it driven by more hours you put into work. Obviously, there's a little bit more time for research because you don't teach as much. That is a small contribution. But in my experience, the most important contributor was basically the fact that with my research experience and all the mistakes I made in graduate school, I was able to leverage that research experience into building effective research protocols, so to speak, to increase efficiency. So I thought to myself, with all the mistakes I made in graduate school that kind of depleted my productivity, I thought to myself, these people in NASA and all these great international agencies, they are solving insanely complicated problems, and they have much higher stakes than I do. So how is it even possible that they are able to solve much more complicated problems involving so many number of people who have their own sets of independent minds? How are they able to get it exactly right in one shot? Well, not necessarily always in one shot, but a lot of times they do. The Mars landing, the JWST launch, they had one shot that they did it. It's not because they're like intrinsically more intelligent than me, it's just because they follow a protocol. And with that insight, I decided that I just need to rigidly follow a protocol no matter what happens. Well, I will not say that I rigidly follow the protocol every single time, but just keeping that in mind, I tend to follow that protocol imperfectly sometimes, but it's just the fact that I do that makes a huge difference. So this protocol is also a very vague term because it's very different for different projects and different fields. But here's an example of a research protocol in my field. So suppose you're trying to develop a software to solve a problem in galaxy formation, say calculating the star formation history of a galaxy. So the protocol would possibly have something as generic as starting with the code development phase. And I will also say while I talk about code development, if you are not using AI tools to accelerate your code development process, you are probably falling behind. Because right now, everybody needs to use AI. It's extremely effective. Something that I was taking 3 days to develop even a couple of years ago, now I can use something as rudimentary as ChatGPT. It's not rudimentary, but compared to other AI tools, it's still a very widespread basic tool. Even that, which is not really built for coding, is able to accelerate my development process by 10 times. So I can do it in 2 hours, what I previously do in 2 days. And then, so please, if you're not using AI, start doing it like yesterday. And then followed by unit tests. The code should obviously be modular, with every part of the module having its own set of tests, so that 2 years later, if you try to use the code, something wrong happens, you can have a set of tests that you can do to every unit of the code and very quickly narrow down as to where is wrong, where the code went wrong. And then obviously the execution phase. And then here's a very important thing that I did not do well in graduate school. Once I have the software package and I am convinced it's working, I have to make sure that it's well packaged and well documented for future use. And there's been times when even 2 weeks later, I went back to a code of mine, which was working perfectly and then didn't work. And I looked at the code and I have to rewrite the entire code because it's complete gibberish. I was the one who wrote the code, but it was still complete gibberish to me. And then the last part, automation, is extremely crucial in my field because it takes 3 weeks to months to even sometimes years to run software to get data. So if I'm not automating my codes, I'm not going to have a single paper in my 5 years of postdoc. So automation is important because in my field at least, it leads to parallelization of workflow. Just as an example of that, this week I was extremely busy with presentation preparation and referee report for one of my papers that's been due for a few weeks. So this is the kind of work that you cannot use a machine to do as much. You need actual brain power. And so I knew that I was going to spend time on this week. So as a consequence of that, last week I scheduled all of my time to develop this software package, which I've been meaning to do for a while. And I was able to, fortunately, before the end of that week, fully automate that software so that as I'm giving you this talk, a code is being executed on Hyperledger, and it's going to generate a lot of data. And hopefully by the end of the week, I'll be able to, the code will finish executing. So once I'm done with my referee report, the outputs will already be available for me to analyze. It's a pretty simple thing to think about it, right? If I'm telling you. And it probably makes a very small difference, this one simple exercise. But think about the compounded effect of that over 5 years of postdoc. It makes a huge difference in productivity. All right. So I talked about the first two pillars, scientific knowledge base and research-specific technical skills. And in my experience, these are really the two pillars that you need to successfully transition from graduate student to being a postdoc. Because these are the ones that will make you into a kind of researcher which people want to see as a postdoc, which is basically independence. Every single person, every single professor that I asked about, the day I graduated, I asked a bunch of professors, what do you expect from me now that I'm a postdoc? There's one word, independence. That's it. And building that scientific knowledge and building that research-specific expertise is the key to get there. But now I have successfully transitioned from graduate student to first postdoc and then to the second postdoc. So the next stage for me that I've been working on for the last 2 years is basically make the next transition from postdoc to faculty. Now, for people who are inspired to get into academia, let me tell you this, that transitioning from graduate student to postdoc is, of course, not the easiest. It's difficult. But transitioning from postdoc to faculty is, at least in my subjective view, 2 orders of magnitude more difficult than the first transition. And the reason for this is that there is basically 2 key requirements for you to transition successfully into a faculty. Of course, you have to take for granted that you must be an independent researcher, that you must already be by the time you're a postdoc. But in order to become a faculty, there's extra elements. The first layer is that you have to find your own academic identity. Find a very small niche of research within the small niche of larger research that you're already part of. find an extremely small niche and build your academic identity around that niche. And that will be a unique contribution to the community, a contribution that no one else will ever be able to make, but not ever, but at this moment of time, which means that you need to also establish scientific leadership within that specific niche. So just to ask the question, when I say, Abhishek, who are you as a researcher? You should be able to summarize, not just you, people around you should be able to summarize immediately as the CEO. What are you really about? In 2 sentences. Who am I? Aklant Bhowmick. I am postdoc right now, but my expertise is basically to develop black hole formation, cosmological simulations. And in this specific niche of cosmological simulation and this specific task of black hole formation, I am the lead. And that is a statement that you have to be able to make. And once you're able to make that statement, that's when you're ready to apply for a faculty position. All right. With that requirement of leadership, this brings to light third pillar of professional development that you need to start nurturing in addition to the first 2 pillars. And this is something, again, it will be very obvious because whether you are a leadership, whether you're pursuing leadership in the political end or the management company end or at the academic end, you need communication skills to be a leader. So pillar 3 is the communication skills. There's 2 sub-pillars to it: public communication and interpersonal communication. Each distinct with its own set of skills. Someone can be a good public communicator, but terrible at interpersonal communication, and vice versa. So let's start with public communication. So for most of us, statistically speaking, public communication is not something that occurs naturally. It's probably like the #1 fear in America, based on some study, I don't remember, public speaking. And I was certainly one of them, and at the very bottom of it. My journey of public speaking has been extremely difficult, and that's a conversation for a different day. But to really briefly summarize, I went from a stage of absolute avoidance of public speaking. Ironically, I joined physics, not just purely out of passion. I kind of lied at the beginning of the talk. It was one of the reasons why I joined physics was because in my view, in my 17-year-old view, I thought this is the field where I would require minimum amount of public speaking and get away with it. And I was surprised and disappointed soon. So it was a difficult journey, as I mentioned, but I've come a long way. And now I'm at a point where, even 5 years ago, if Abhishek came to me and just told me that I'm supposed to give a talk at the Navigating Academia series, I'm like, this is not a talk that I have to absolutely give to publish papers and graduate out of my Carnegie Mellon. So no way I'm going to give this talk. I'll just avoid it. But now he came to me not just him, but a few more people came to me a few months ago talking about, I'm like, great, I would love to speak about that. And I still feel on edge when I'm speaking or when I'm preparing to speak, but it's still a huge difference compared to where I come from. And I'm really excited to see where this part of my journey leads to. And this is extremely important because in my experience again, the importance and the frequency of public communication will only increase over time. So in my story, as an undergraduate, the number of high-stakes talks, not even all talks, but the number of high-stakes talks I gave was maybe about 2 to 3 times in 5 years. And then later on in my PhD stage, it was about 2 to 3 talks a year, depending on how many conferences I would attend, depending on the availability of funding. But once I became a postdoc, on an average, I have been giving 1 high-stakes talk every month. And that's just on an average. During my peak of the job season, which was last year from December to about April or so, I was averaging 3 to 4 high-stakes talks every single month, including all the job talk interviews, conference visits, and all the other seminars that I was attending, just because I wanted to establish leadership in the field. That's what it takes to establish, because it's not just enough for you to think, oh, I'm a leader. If others don't agree that you're a leader, you're not a leader by definition. So people need to think that you're a leader. So you have to convey that assertively. Okay. I will also quickly highlight one really amazing platform that I use to nurture, and I continue to use it to continue growing my public communication skills, which is Toastmasters International. It's a fantastic platform for practicing public speaking at every single level. There's multiple pathways if you want to be an academic speaker or inspirational speaker or political speaker. There are all sorts of different pathways, and you can become a very versatile public speaker within a very short time. And so there's multiple clubs in Gainesville, and it's available for a really minuscule fee compared to a lot of other activities that you may pay for. So if you are interested in joining Toastmasters, please feel free to talk to me after the presentation or anytime. Next pillar is interpersonal communication. So interpersonal communication is something that people generally don't explicitly talk about, but especially over the last few years, I really realized the importance of interpersonal communication in my pursuit to establish leadership in the field. So back in my graduate student days, when I used to go to conferences, I would just shy away from talking to people because I didn't want people to think I was dumb. But I realized that this is just not going to work. And now when I go to conferences, I make it a plan to have at least 2 conversations. It's not always fun to have these conversations that you do. Sometimes you just want to go and have fun because you're in Belize, Puerto Rico, and all sorts of different places for conferences. But just keep a limit, minimum, maximum limit, 2 to 3 conversations with people that you want them to know that I'm the next leader of this particular niche and you better know me. So one thing that I noticed when I really look back on my time with the perspective of the importance of interpersonal communication is that as a graduate student, when I look at the papers, majority of my papers were born out of my advisor's ideas. And perhaps there was one paper that was born out of interpersonal interaction that I had at a conference. Once I became a postdoc, suddenly it was a complete flip. I just realized that except for the first 2 papers that I wrote with Laura, the vast majority of my other papers were basically ideas that spawned as a consequence of some interaction I had with someone at a conference. And this is natural because you are, by definition, independent researcher. So where are the ideas going to come from you? But your brain is limited. But once you have conversation, it's like an expansion of the brain. Because you're talking to other people who have their own set of experiences. So bottom line, fewer one-to-one interactions will translate into fewer project ideas. So I highly encourage you guys to push through the shyness if you have that issue. I definitely did, and have more and more one-to-one interactions. I will also quickly highlight my first faculty on-site interview, which I had. It was a fantastic experience at Oregon State. Ultimately, they didn't take me. They lost. But it was a really good experience because it really hinted that I was making progress. After 2 years of not hearing from anything, I heard from one. And there's a stochastic process. It's a different conversation for a different day. But it really hints that you are making progress. I'm making progress. So the interview lasted for 2 days. The first day was a 20-minute teaching demonstration, followed by 5 hours of one-on-one meetings. Second day was 6 hours of one-on-one meetings with half an hour of rest, and then an hour-long group. So it was an arduous process to interview for these faculty jobs. It's a fun process, of course, but you can also notice that the bulk of the conversations or the bulk of the interviews basically these one-on-one conversations with people from a wide range of different fields. And so you have to get used to talking to people from different fields, having a one-on-one conversation and be able to generate intelligent thoughts. In the last few minutes, I will talk about the final pillar. And this is something that we are all implicitly aware of, but no one talks about it. Well, I'm going to talk about it. I have no other label for it other than just labeling it emotional skills. Because the fact of life is that emotions, whatever we go through in our minds and in our hearts, they affect every aspect of our life, and academic process is no exception. So the question is this. Do we want to enter a positive feedback cycle where we have emotional well-being, which translates to higher productivity and which translates to emotional well-being, and it leads to a positively vicious cycle? Or do you want to go to the other direction, which is a negative cycle? Unfortunately, it's an unstable system, so it's either that or so, or you are in a negative emotional state, so it leads to translates to bad productivity, badly impacts our research, and then it's a negatively vicious cycle. So what I realized was this is a very difficult problem, but I had two realizations which really helped me tackle it and continues to help me, and it's an everyday process. The first realization was that well-being does not translate to having a goal mindset. Because if you are having a goal mindset, goals only happen maybe once or twice in a few years. So do I really want to base my happiness around that? It would mean that I would only be having a high of happiness once or twice in a year, and that is not an acceptable way for me. So having a growth mindset where I translate each and every iota, each and every infinitesimal progress that I make and learn how to translate that into a sense of emotional well-being is a skill onto itself, because the brain is not wired for that. The brain is wired for some kind of tangible, very visibly tangible rewards. So that's why I call it emotional skill, because it does not occur, it takes practice. And in the scientific context, it basically means to realize that science is a process and not the outcome, because anybody can claim any outcome, right? People are already doing it. But the reason why we are scientists is because we are engaged with the process to get to the outcome, and we are spending 99% of our time in the process. So if you're not deriving joy out of 99% of the work that you do, then 99% of your life is unhappy. And you have to decide for yourself if that's an acceptable way. To me, it's not. So, but I will also say that even if you love the process, it's like a child. You can love the child, but you can also throw tantrums. So there's going to be daily fluctuations and daily ups and downs, and sometimes you can just hit a wall. And the question is, how do we handle that? Again, a very difficult problem. I'm not claiming to have an ultimate solution for that, but I'll just tell you what helped me. And this brings me to the second realization, that just like how some of you might be investing in stocks and index funds and mutual, whatever you do, how do you handle these ups and downs? By diversifying, right? Because something goes down, something else goes up, so hopefully it's a stable system overall in the longer term. So that's what I've done. So I have a diversification of interests so that I can measure growth every day, not just in one channel of academia. I can measure growth in multiple channels. So I have my workouts, occasionally I ski and hike, and I'm a social dancer, salsa, bachata. I'm also an instructor. I play the guitar occasionally. So during times when, and there has been times for months and months, I just felt stuck, no progress. So all that growth mindset goes out the window. Diversification helps me during those times because I can pursue growth in other avenues, which translates to emotional well-being, which helps continue that positive feedback cycle. Yeah. So, in conclusion, these are the 4 pillars of professional development which I personally have framed in my mind. These are the pillars that I need to simultaneously work on to ensure that I have a successful academic life. And with that, I will just conclude by saying that academia has been a huge blessing for me. That's challenged me in so many different ways. I've learned a lot during this process, and I've also had a fantastic community to support me. And that is precisely why I want to pursue academia, despite sometimes having attraction from that greater financial incentive from industry, which is the topic of a different day. But I love academia, and that's why I want to continue to succeed, and I look forward to it. With that, thank you very much. Hopefully, this is valuable.
Do you have questions for Aklant?
Yeah, you said this is your 5th year?
This is my, I'll finish my 5th year.
And this is your first and only postdoc?
Yeah, correct.
It seems that it's kind of arbitrary as far as how long postdocs can last.
Yes.
I know multiple people have been on multiple 2-year ones roughly, give or take. Like, how did yours end up being 5?
So there's a lot of factors that depend. One thing is that once you become from a graduate student, you graduate and then become a postdoc. It's a very tangible. You defended your thesis, so it's a monumental event, and then you become a postdoc. But in reality, if you don't account for the fact that you get a greater salary once you become a postdoc, it's really a continuous transition. And that transition is basically, in my mind, I take it as just going from graduate student postdoc does not mean I've defended and now I'm a postdoc. It just means that I've worked myself up, that I now feel like an independent researcher. Same way, as a postdoc to faculty, I now feel like I'm a leader, so I'm ready to be faculty, even though I'm not a faculty right now. So that being said, that length of time, whether you do one or two postdocs, or you do just one longer postdoc to a faculty, it really is just a matter of, I mean, I won't say it's perfectly just a matter of semantics, but it, first order it really is, because it's really the amount of time and the amount of people that you need to meet and who need to get exposed to your research for them to feel and for you to feel that you are a leader in your field. So there's exceptional cases where students have gotten a faculty job right out of grad school. I personally know, and it pisses me off when I hear about that. But the reality is that there's people who are able to just establish, maybe by dint of luck, by dint of hard work, but for a lot of reasons, it's a very stochastic process. They're able to establish leadership in the community with maybe one paper or maybe a series of papers, and they're able to directly transition from postdoc, from graduate student to faculty. And then there's people who are spending 9 years, 10 years as a postdoc. And then on an average, if you draw a distribution, it's like 5 to 6 years and the number of postdocs too. But all of that is just semantics. And for me, one factor that impacted my length of time that I spent specifically in University of Florida, I would encourage people to go to different places because that's how you gain exposure, not because you have to do 2 postdocs or 3 postdocs. Only because of that level of exposure. But in my case, unfortunately, I was an international student from India, and it was very difficult to get, the green card situation is very difficult. I did not want to get a J1 visa. So these are these other variables which I was asked to talk about, but I just couldn't find time. So I'm glad you asked. So for international students, the equation is a little bit different. But I've also felt in my, I've talked to professors and I asked them, is the fact that I stayed in the US for a really long time, much longer than typical postdoc duration, is it a liability? And they just look at my CV and they're like, no, absolutely not. I mean, it sounds like it worked out for you. So it's fine, as long as you figure out other ways to establish leadership.
I was wondering how you got your first postdoc. Like, did you know Laura Blecha before?
No.
Or
It was again a bit of a. So I was, in my opinion, I was not ready to apply for. So if you really look at my papers, sorry. So I joined computational astrophysics in the middle of 2016. So it was a bit of a difficult process, and yeah, it does look like on paper I graduated with a PhD out with 6 papers, which looks like a lot. But at the time when I applied, 2019 was when I applied. This paper, so I had 2 papers, and this paper was basically on it was a major revision. So I basically had 2 papers. So I had no hopes of really getting a job. But luckily, I was able to finish this paper. My advisor encouraged me to finish this paper, and I was able to do it. It was a shorter paper, and I already had the machinery for it, so it took me maybe like a month to post that paper on archive, not getting accepted. But my theory is that Laura took notice of this multiplicity function of quasars paper. It aligned with her interests. I did not get her first offer, but I got the second offer. So, and I applied to other places, and I did not get. So I think part of why I got selected was a bit of Poisson error, but also because my advisor encouraged me to write up this paper quick, and I believe that that made a difference. If I were to do it all over again, I would have waited another year to graduate at a different time frame. Because what happened, if I had done that at that time, I would have encountered the pandemic. So it would not have worked out. So I was really lucky at the time. So I'm glad that happened. But also, I felt like I would have had a better chance with like the priced postdoctoral fellowships. I tried for the Hubble Fellow for several years and I did not get it. And part of the reason was because there's a limited time after your PhD to apply for the Hubble Fellow. So there is, of course, there's an incentive to graduate early, but I also encourage you guys to think about establishing your like going further with establishing your research identity before you graduate so that you have more time to apply for the Hubble Fellowship after you graduate. So that's a game that you can play and it's optimization cost depending on what you value.
So a graph that caught my eye was through the first pillar, the almost that sinusoidal wave.
Yeah.
Your knowledge base, it's true.
Investment in knowledge base.
Yeah, your investment in knowledge base, like if I very much resonate with that.
Yeah.
And so I guess my question to you is, as graduate students, how do we not let that plummet? How can we, what can we do better to, keep that, at a fairly good level?
I mean, more than the question of how do we not let that plummet, it's a question of what are your priorities and whether you can afford to let that plummet depending on your priorities. And I don't necessarily think it's a bad thing. For me, it kind of worked out because obviously I'm here. So it kind of worked out that I decided not to invest so much time in scientific knowledge base because I really had to build up a new set of research-specific theoretical expertise. Because joining a new research group it was, I think, 2.5 years after I started my grad school. It was really late and it takes a long time to gain those research-specific skills. So I decided to just let it fall by the wayside and prioritize for the moment, building that theoretical expertise, publishing a lot of papers. And I'm not going to claim that I've gained profound astrophysical insights by publishing those papers. I just got really good at this technical things that I needed to do, and I received scientific support from my advisors. So you also want to think of your advisors as not just like these people who you look up to and pray, but also as useful resources. They all have their expertise. And if you are able to, if you can gauge that your advisor can provide you the required scientific expertise, then it's something that you can leverage. There's nothing wrong with that. And they also have a limitation. Every advisor will have a limitation. So you have, in addition to looking up to them, you also have to look at them very like straight in the eye. And what are your limitations? What are your? This is the way I will approach you. This is when I will. This is the task for which it will be helpful for me to approach you. This is the task for which this is not going to be particularly helpful for me to approach you. It's a very practical way of looking at your not just your relationship with your advisor. Advisor is not your only advisor. It's just an official advisor. You have your entire committee. You have your entire department. You have your postdocs. Everybody is a resource, and you want to learn how to leverage all of them, not just your advisor, just because they are your official advisor. The whole world is your.
If you don't have any other questions, let's just thank Aklant again.
Thank you very much.